Hello, my dear students. Welcome to IMS GATE Academy and welcome to the foundation course on geotechnical engineering. And my dear students, if you are really preparing for the public sector companies, GATE is the only way where you can be selected or where you can enter into the public sector companies. My dear students, the agenda of the foundation course is, if you are studying about geotechnical, the basic properties and the basic topics you should be very clear. Suppose, see, I will tell you a small example, students. When you want to make interest of any subject, if your basics are strong, definitely you will show high regards to that subject and you will try to read more and more. The agenda is not only covering the foundation course, we are also giving you the, good afternoon Srujna, we are also giving you the best GATE examples. If you have visited our IMS YouTube channel, you have seen, if you have seen the properties of soil topic or permeability topic or soil classification, remember my dear students, I promise you that by solving the examples in the previous GATE problem, by solving the previous GATE questions, you will understand. If your concept is clear, definitely you will have high chances and you will feel that it is also easy. So let us start the today's topic, effective stress. So when I start about the effective stress, sir, what do you mean by the word effective? Sir, suppose if the work is done, there is a called effective work. So what is an effective work? Okay, in any job or any work, we talk about the effectiveness. See, that is which is fruitful. So why we want to study about the topic effective stress? Here we are going to study the topic effective stress. Okay, my dear students. First of all, before reading the stress topic, what is a stress quantity, my dear students? A stress is a vector, or a stress is a scalar, or stress is a tensor. My dear students, how many of you will agree that stress is a vector, or stress is a scalar, or stress is a tensor? And for your information, my dear students, this was one of the interview question which was asked in TCS exam for a mechanical student. So my dear students, a stress is nothing but a tensor quantity, TENSOR, which you might have studied in strength of materials also. So I'm not going in detail what is a stress and all these things. For now, you have to understand a stress is a tensor quantity where it has direction, magnitude, and it can have more than two planes where it is acting. The plane in which it is acting also, if you talk, then we discuss that it is a tensor quantity. So it is as simple as that. Now, what is a stress quantity? Stress is a tensor quantity. Agree, Srijana? Now, why do you want to study about the effective stress? Suppose, my dear students, if a load is applied on me, okay, how much load is taken by my foot? How much load is taken by my hand? How much load is taken by my legs? So you will differentiate that. Similarly, see students, whenever you are talking about geotechnical engineering, I told you so many times, the whatever the load which is falling on the slab has to be transferred to the beam and to the column and then to the footing. But where does this footing is resting? The footing is resting on the soil. When you apply the stress on the soil, so there will be some, when you apply some load on the soil, definitely there will be stress induced. So how this stress is going to transfer? Sorry students, how this stress is going to transfer? See here. Are you able to understand, my dear students, how this stress is going to transfer? Okay, for your information students, a effective stress is nothing but the intergranular pressure. It is, in loose words, it is the pressure transmitted between the soil particles. From one soil particle to the other soil particle, how the stress has been transformed. That is nothing but the effective stress. So here I am showing you, if the soil cannot be placed like a straight lane, or it is of different shape. So how this stress has been induced between the soil particles, if you want to study, that topic is nothing but the effective stress. Is it clear, my dear students? Is it clear, Srujana? Can you please comment? So here, when I talk about total stress, total stress is due to two things. Total stress is due to, one is due to self-weight and other one is due to overburden. What is overburden? Any load other than self-weight can be taken as overburden. So my dear students, on the soil, there can be a structure placed. So whatever the stress that is induced due to the structure can be a overburden and the self-weight will be the. So there can be two chances how the total stress can be induced. The total stress can be induced, one due to self-weight and other one is due to the overburden. Are you following, Srujana? Is it clear? Okay. Now, here my dear students, I will tell you very important thing. Total stress can be written as effective stress plus U. See, this beautiful thing you have to understand, my dear student. So whatever the total stress is there, it is taken as summation of, total stress is taken as a summation of effective stress and what is U? It is nothing but the pore water pressure. It is the summation of effective stress and pore water pressure. Now, what is effective stress? It is the intergranular pressure. See, my dear students, whatever the pressure which is transmitted between two soil particles, that is nothing but the effective stress. Sir, what do you mean by pore water pressure? Very good, Srujana, very good. What do you mean by pore water pressure? My dear students, when I talk about the pore water pressure, Srujana, I really appreciate you, because what I have observed is right from my first lecture, you are attending the classes regularly. My dear students, in GATE, not only hard work, consistency is very important. When you are attending the classes, even though you are taking the GATE coaching, if you are not attending the classes regularly, there is no use. But one good thing I have observed from Srujana is she is attending the classes regularly and she is following the class. And if she can write these short notes also, definitely there will be a good results in the coming GATE exam. So here when I talk about pore water pressure, if you see, students, in between the soil particles, there is some voids. In between the soil particles, there is some voids. Whatever in these voids can be filled with air or water. If the voids are filled with water, whatever the pressure that is developed due to the water is nothing but the pore water pressure. And remember, my dear students, Pascal's law states that this is a very, very important concept in earth pressure. For now, just remember this. Pascal's law states that the pore water pressure is same in all directions. Suppose if you take a resultant, you will resolve into horizontal component, that is F cos theta, and if you resolve into vertical component, F sin theta. But what does Pascal's law states? It is same in all the direction. That means horizontal component can be equal to the vertical component. Any direction, the pressure will be same. So here, my dear students, you have to write a note that total stress is a summation of effective stress plus pore water pressure. What is effective stress? It is the intergranular pressure between the soil particles. Okay, and one beautiful point I would like to tell you, students. If you see here, total stress is effective stress plus pore water pressure. Now, my dear students, if you want to find out the effective stress, we always find out that total stress minus pore water pressure. You cannot find out the effective stress directly until unless you know the total stress and anyhow pore water pressure based on how much the water has raised. Through that, you can calculate the pore water pressure. So that is the reason effective stress can be calculated by knowing the total stress and the pore water pressure. So please write down this point, my dear students. Effective stress is the difference of total stress and the pore water pressure. And now I'll tell you one important thing. How do you write a stress? Stress is nothing but load upon area. Stress is nothing but what? Load upon area. So my dear students, if you see what is the unit weight of soil? What is the unit weight of soil? Unit weight of soil can be written as gamma is equal to weight upon volume. And here you can write weight is equal to gamma into volume. Okay. And how can you write volume? Area into height. So here you can write gamma into area into H. What is this? H is depth of the soil strata or thickness of the soil strata, whatever you feel. So if I substitute here sigma is equal to W upon A, you can write it as gamma into A into H upon A. So you can write this as gamma into H. So actually I just want to tell you how you will write the total stress in terms of unit weight, my dear students. In terms of unit weight, you can write the total stress as gamma into H. Is this clear, my dear students? So remember, sir, I promise you, I will tell you 5 to 6 cases, and if you follow these cases, effective stress easily you can solve them. Okay. Very good, Srujana, very good. The first one, what I would like to tell you here is, suppose if I consider a soil strata having a depth of Z. I'm considering a soil strata having a depth of Z. And the unit weight of the soil is gamma. Okay. Now, my dear students, how I will draw the total stress? First, see students. How I will draw the total stress. Now see students, I would like to tell you one important thing here. What is the important thing? What I would like to tell you is, this is the total stress, this is the pore water pressure, and this is the effective stress. So my dear students, how the stress is going to vary is, the stress is going to vary hydrostatically or it is going to vary linearly. That is the first point you should understand. So here if I try to write what is sigma. Sigma is nothing but total stress. And I told you what is gamma, unit weight of the soil, and what is Z. Z is the depth of soil strata. So here, my dear students, you can write total stress as gamma into Z. Now, is there any water table? There is no water table. My dear students, if you talk about pore water pressure is 0 here. When do the pore water pressure will be 0? When will be the pore water pressure will be 0? If there is no water table, pore water pressure will be 0. So this is equal to 0. And here, how do you calculate effective stress? I told you, effective stress cannot be calculated directly. It is the difference of the total stress and the pore water pressure, and this is written as gamma into Z. So what is the conclusion you have made here? Srujana or anyone, my dear students, what is the conclusion you can make from this diagram? What is the important note point I would like to ask you? Okay, anyone, my dear students, if I talk, there is a soil strata having a depth Z and unit weight of the soil is gamma. So what is the question I would like to ask you is, we have calculated the total stress, We have calculated the pore water pressure and we have calculated the effective stress. Can you tell me what you have observed from this diagram? Anyone? So what is the observation? What I have observed is total stress, my dear students, here you can write it as a note. You can write it as a note that total stress is equal to effective stress. What, sir? Total stress will be equal to the effective stress. That is the very important point. So write down, my dear students, in case of no water table, whenever there is a no water table, total stress will be equal to the effective stress. Total stress will be equal to what, my dear students? It will be equal to the effective stress when there is no water table. That is a very, very important point. Okay. So actually, my dear students, you have told me pore water pressure. You have told me pore water pressure. What is pore water pressure? What do you mean by pore water pressure? Pore water pressure is denoted by a letter known as U. And you have told me already, Pascal's law states that pore water pressure is same in all directions. Actually, pore water pressure is given by the formula. It is due to the water, gamma W into height of the water. So there, if you see in the diagram, there is no water content. So height of water will be 0. So gamma W into 0 will be 0. And important thing, please write this as a note, students. Pore water pressure is also called as neutral pressure, my dear students. Pore water pressure is also called neutral pressure. Now comes the very, very important point which I would like to tell you. Students, whenever you are talking about soil, which stress is taken into account is only the effective stress. But you will never consider the pore water pressure. You will always consider the effective stress. Why? Because effective stress has an influence. It has an impact on the engineering properties. That is like permeability, shear strength or compressibility. My dear students, pore water pressure is called neutral pressure because it does not have any influence on engineering properties. As it is not having any impact, it is called as neutral. Sir, I am a neutral candidate. I won't support anyone. That means pore water pressure is a neutral pressure because it has no impact on the engineering properties. Is this clear, my dear students? So, another important thing, student, we at IMS GATE Academy are offering the offline GATE coaching. We can proudly say that we are the only institute which are providing the offline GATE coaching at Vijayawada. And my dear students, if you want to observe the exercise book, theory book or multiple subject test, advanced level subject test, we are also providing the offline GATE coaching at Bangalore Jayanagar Center. You can visit our office and we are providing the demo sessions also. Anyone who is interested, they can attend the classroom sessions also. And one more thing, my dear students, here when I talk about the pore water pressure, that's all. Now let us see. Suppose here we have a soil strata with a depth Z1. This one is case 2. We are having a soil strata with case 2 with different unit weights. Here we have depths Z1 and Z2, and here you have a unit weight of gamma 1 and gamma 2. Are you following, my dear students? Now, how do you represent the total stress? How do you represent the total stress? Here, see, student. How do you represent the total stress is? Okay. Here you can write it as, my dear students, here you can write it as gamma 1 Z1, and here you can write it as gamma 1 Z1 plus gamma 2 Z2. And I am not writing pore water pressure here because pore water pressure is 0. Am I correct or wrong? There is no water table there. So pore water pressure is 0. In this case, total stress will be equal to the effective stress. Now, my dear students, I have done intentionally one thing wrong. Can anyone observe? I would be very happy. I have done intentionally one thing wrong here. What is the wrong? Because when you are solving the gate questions, the common mistakes I also want to explain you. Because here, my dear students, if you see the gamma 1 here, it is having a unit weight of gamma 1. Here the unit weight is gamma 2. Now, if you see the diagram, you are showing the slope is same. Sir, that slope will be same if the unit weight is same. Entire soil is having same unit weight, then the slope can be same. If here, my dear students, if you observe here, there are two different unit weights. So here, my dear students, the unit weights are different. So the slope will also change. So if you observe here, it is gamma 1 Z1 and here it is gamma 2 Z2, and anyhow this will be gamma 1 Z1. So gamma 1 Z1. So are you clear, my dear students? So what is the note point? What is the outcome of this soil strata? When soil is having two different unit weights. Sir, when it is possible, actually you will ask me, sir, when can a soil have two different soil unit weights? There can be a clayey soil, and in the beneath the clayey soil there can be a sandy soil. So there can be two different unit weights. In this case, if you observe the stress, my dear students, the stress is going to vary. How is the stress is going to vary? The stress variation, if you see the slope is going to change, my dear students, which is very important observation. Okay. And next, my dear students, if you talk about a surcharge. Sir, what is a surcharge? What do you mean by surcharge, my dear students? It is a kind of a constant load. See students, actually, if you see the type of loading, there is a type of load. We have different types of load. In RCC also we have impact load, we have a dead load, we have a live load. What is dead load? It is nothing but the self weight. What is live load? The benches, chairs, cars, and all these are live loads. And what do you mean by surcharge here, my dear student? A surcharge is nothing but a constant loading. A surcharge is nothing but a constant loading. So it happens, see, on top of the soil, there will be a building for 50 years. Imagine what is going to happen. There is a continuous loading. So you might have heard the term creep. Creep is a term in strength of materials which is coming due to time. A long term, that word long term is associated with time. So creep is a long-term deflection under constant loads. What is the word? Constant loads. Srujana, are you following? Now see students, if I consider here, there is a soil having a depth of Z. So if you consider here, my dear students, if you consider surcharge loading of Q, if you consider surcharge loading of Q, so here how the stress is going to vary? Here the stress, how is the stress is? The stress is going to uniform. Here also it is Q, here also it is Q. So my dear students, you should understand that in case of stress, in case of surcharge, the stress is going to be uniform. In case of surcharge, the stress is to be uniform. What I have observed in the previous case, the stress is going to vary hydrostatically. The stress is going to vary hydrostatically whenever there is a gamma, but in case of surcharge, the stress is going to be uniform. This is a very, very important point, my dear student. Next. Now see students, we have studied with different unit weights and all. Now we will discuss about In case of, sir, see, for every diagram, I am giving you the note. If you can find the note, how easily you can solve the problem, I will be explaining you also. Now see, in case of water table, what happens, we'll see. So in case of water table, suppose see students, if we have a soil strata, if we are having a soil strata, having a depth Z, and there is a water table here. Now, my dear students, most of the people should understand, whenever there is a water table, what is the condition of the state of the soil is, it will be saturated in state. What will be the condition of the soil? Because in case of water, the voids are completely filled with water, then the unit weight will be considered as gamma sat. So here, my dear students, if you see the total stress distribution diagram, this will be equal to sigma is equal to gamma sat into Z. And if you observe the pore water pressure, the pore water pressure will be equal to gamma W into Z. What is how do you know pore water pressure is gamma W into Z? How do you know pore water is gamma W into Z? See student, I told you clearly sigma is equal to unit weight of the soil into depth of soil strata. So gamma sat into Z. If you talk about pore water pressure, it is also gamma W into height of water. What is the height of water here? It is Z. So you have written as gamma W into Z. And now, my dear students, if you find the difference between the total stress and the pore water pressure, then this can be written as, gamma sat minus gamma W into Z. Because, my dear students, please see here, if I have taken Z common from these two equations, gamma sat minus gamma W. But what do you mean by gamma sat minus gamma W? Gamma sat minus gamma W is nothing but gamma dash. So this can be written as gamma dash into Z. This can be written as what? Gamma dash into Z. Am I clear? So here we talk about the total stress. Here we also talk about the pore water pressure. And here we have the effective stress. This is called effective stress. So when I talk here, effective stress is the difference between the total stress and the pore water pressure. So you represent the effective stress as gamma dash into Z. And my dear students, in your college or in any, when you are seeing the stress distribution diagrams, one observation you should also follow, Amma. Sir, see, if I show you the depth here, if I show you the width, I have shown you larger width. If I shown you the width here, I have shown you slightly smaller. Here, if you see here, if you are not comfortable, okay, here the width is much smaller. Sir, why I am showing the width here larger, here smaller, much smaller? Because if you see, if you understand the properties of soil topic, my dear students, I told you clearly that gamma sat is far greater than gamma W and gamma W is greater than gamma dash. Because in all the three cases, you are Z is common. But what is varying? The unit weights are varying. And you are pretty sure that gamma sat is greater than gamma W and gamma W is greater than gamma dash. So that is the reason you can say that these variations have been shown. Is it clear, my dear students, Srujana? And one more thing, what I would like to tell you here is, in case of water table, you can write as a note, whenever you are finding the effective stress, this is what, sir? Effective stress. Whenever you are finding the effective stress, please write it as a note. Gamma sat will be replaced by gamma dash. What, sir? Write down as a note. I am telling you the clear shortcuts. I will show you how easily we can solve the problem also. So Please write down, my dear students, in case of water table, during the calculation of the effective stress, gamma sat will be replaced by gamma dash. Okay. Now see students, I will show you one simple example here. Okay. Now there is a surcharge loading of suppose 50 kilonewton per meter square. Surcharge loading is 50 kilonewton per meter square. Okay. This soil is having a depth of 1 meter and there can be dry unit weight is 18 kilonewton per meter cube. Okay. And here you have a water table. This is equal to 3 meter. Okay. And here gamma sat is taken as 21 kilonewton per meter cube. They might ask you what is the, suppose if I have taken this as A layer, this as B layer and this as C. See students, how you will calculate the effective stress at point C. Suppose calculate effective stress, calculate the effective stress at a plane CC, or I will write CC dash, okay, B dash and A dash. He is asking calculate the effective stress at this location. So what will be the effective stress, sir? What will be the effective stress in this case? Any doubt? What will be the effective stress in this case? Sir, see, I will tell you the simplest way. See students, there is a surcharge. So it will be constant throughout. So it will be 50 at A, at B also 50, at C also 50. And what is the stress due to this? This will be equal to 18 into 1. Okay. And how do you calculate the stress? There is a water table here. I told you clearly, whenever there is a water table, to calculate the effective stress, gamma sat will be replaced by gamma dash. So here you can write it as 21 minus 10. I am assuming, sir, for easy calculation, I am assuming gamma W as 10 kilonewton per meter cube. Actually, for easy calculation and for your better understanding, I am telling you. Actually, gamma W is what, my dear students? It is equal to 9.81 kilonewton per meter cube. But here, for easy calculation, I have taken gamma W as 10. So, 15 plus 18 into 1, 20 minus 10 into what is the depth? Here it is 3. So, you can write 15 plus 18, 68 and 11, 3, 33. 68 plus 33, how much, my dear students? It might be equal to 101 kilonewton per meter square. So, what is the logic I have applied here? Sir, this is a single line step, how you can solve the problem. The first is 50, there is a surcharge. The stress is uniform in case of surcharge. As the stress is uniform in case of surcharge, it will be 50 at A or BB or CC. So you can write here as 50 plus, here it is 18. So this is 18 into 1, you can write it as 18. And there is a water table here, student. As there is a water table here, in case of water table, gamma sat will be replaced by gamma dash. So I have applied the three concepts and I have done it as one at one. So let us solve how we can do individually. If you want to see the diagram, sir, here there is a surcharge load. How much, sir? This is 50. So if I consider here, it will be 50 at top and it will be also 50 at bottom also. Because the surcharge variation is how? It is uniform. And here you have a dry unit weight is 18 and gamma D, and what is the depth? It is 1 meter. So here, my dear students, if I draw here, this will be equal to 18 into 1. This will be equal to 18 into 1. So if they ask you at AA plane, okay, it is 50. At here it will be, this value is 50 plus 18. So this value will be equal to 68. Okay. Now see students, here there is a water table. So, and you told the gamma sat is equal to 21 and the depth is 3 meter. So what I have done is, I will show you like this. This portion, whatever the portion you are having, okay. Why I am changing the slope here? Because gamma set, and this portion will be equal to what, sir? This will be taken as gamma dash into z, because there is a water table here. So this is equal to 20 minus 10 into 3, that is equal to 33. So this portion is 33 and this is 18. So what is the value if you add all these things? It will be equal to 101. So they can ask you, what is the effective stress at the top? What is the effective stress at top? It is 50. What is the effective stress at the middle layer? That is B. It is equal to 15 plus 18, 68 kilonewton per meter square. Okay. And see students, if they can ask you, beautiful thing, what they will do is, what they can do is, they will give you the specific gravity and void ratio, and they will not give you gamma D and gamma set. So if they give you specific gravity and void ratio, you should know the dry unit weight is given by the formula. Dry unit weight is given by the formula gamma W into G upon 1 plus E. Using this formula, you can calculate the effect, you can know the, or you can calculate the dry unit weight. And if they have given you G and E, you can also calculate gamma set, that is gamma W into G plus E upon 1 plus E. Sir, now what you have observed here is, remember students, if you don't know the concept of property of soils, then you cannot do this problem. That is the reason we have taken this as a note. Okay, students, there might be some concept useful in strength of materials in soil mechanics. So we also made some multiple subject tests. And if you see these kind of tests we are providing you at IMS India website, you can visit IMS India GATE website, IMS India, and type GATE. There is a program called Zero Fee program. There we have uploaded 6 subject tests, chapter tests. You can visit that website and enroll for those tests. There you will observe why it is important, my dear students. Okay, just 2 minutes, students. Students, you might have followed the problem, how easily you can solve it. So the beautiful thing what we have to observe here is, if you know the concept, my dear students, any problem can be solved. And one more thing, students, suppose if I told you here the soil particles, okay, now there can be here voids. This I'll assume this part as voids. This part, if I assume this as voids. So here, my dear students, there is a load which is going to apply. Okay. So here, my dear students, what I would like to tell you is, the intergranular pressure between the soil particles is known as effective stress. Agree or not? So if you consider here the voids, these voids are filled with what? Voids are filled with water, right? and whatever the water which is filled in the voids, that water exists in three forms. Whatever the water which is filled in the voids, that water exists in three forms. One is structural water, and other one is adsorbed water, one is structural water, adsorbed water, and next one we have is the capillarity water, and next one we have is the capillarity water. So here what I would like to tell you here is, the water exists in the voids. The water is going to exist in the voids in the three forms. One is the structural water, another one is the adsorbed water, and other one is the capillarity water. So what is a structural water? I'll tell you simple example. In blood, if you take a blood, there will be red blood cells, white blood cells, leukocytes like that, or erythrocytes and all, same red blood cells and all. So similarly, what I would like to tell you here is, the water is going to exist in three forms. One is the structural water, adsorbed water, and capillarity water. So what is actually structural water? So what is actually a structural water? So here, my dear students, a structural water is an integral part of the soil. Structural water is an integral part of the structural water is an integral part of the structural water is what? It is an integral part of the soil. So here, if you see, if I consider this as a void or this is a soil, the structural water will be something which is like very close to the, means it is mingled with the soil. And remember that, sir, this structural water, as it is an integral part of the soil, it cannot be removed by, ordinary oven drying. Are you getting, my dear students? Please write down. They can ask you in IES or any one of the objective questions. Water exists in the IES prelims or SSC JE also. We observe this question. How does the water exist? The water exists in three forms. One is the structural water, another one is the adsorbed water, and another one is the capillarity water. And remember, this structural water cannot be removed by ordinary oven drying because it is an integral part of the soil. As it is an integral part of the soil, it cannot be removed by ordinary oven drying. And next one we have is the adsorbed water. Next one we have is the adsorbed water. Now here, what is adsorbed water? I told you already, my dear students. When I talk about soil structure, I told you, whatever the water held due to electrical forces, the water held in the zone of diffuse double layer, the water held in the zone of diffuse double layer is known as adsorbed water. And remember, my dear students, adsorbed water will create plasticity. Sir, what? It creates plasticity. And remember, my dear students, plasticity is not a good sign, because consistency means it is the property of the soil which does not allow the soil to deform. Plasticity means it will allow the soil to deform without rupture. So plasticity also it should not cause. And the next one we have is the capillarity water. Next one we have is what, sir? Capillarity water. Now when I talk about the capillarity water, what do you mean by capillarity first of all? My dear students, when I talk about capillarity, what do you mean by capillarity? Sir, capillarity is nothing but the rise or fall of a liquid. What is capillarity? The capillarity is nothing but rise or fall of a liquid. The rise or fall of a liquid is known as capillarity. First of all, the rise or fall of a liquid is known as capillarity. Now, what happens, how this capillarity water comes in the concept of soil mechanics? See students, the interconnected voids, suppose the interconnected voids, these are the interconnected voids here. These interconnected voids will act like a capillarity tube. What, sir? The interconnected voids will act like a capillarity tube. From this tube, either water will rise or water will fall. Sir, when will the water will rise? Suppose if there is a melting of ice, suddenly the water table rises. Suppose that is called melting of ice. Suppose there can be a freezing of water also. Suddenly then the water table will come down. Are you getting me? So here there can be melting or there can be freezing. Due to that there can be a rise or fall. So what happens is the interconnected voids will act like a capillarity tube through which the water will rise or fall. That phenomena is known as capillarity fringe. That phenomena is known as what, my dear students? It is known as capillarity fringe. So please write down here, my dear students, what do you mean by capillarity fringe? Interconnected voids will act like a capillarity tube. Interconnected voids will act like a capillarity tube through which water rises or fall. Through which water will rise or fall. So this phenomena is known as capillarity fringe. And due to this capillarity fringe only, my dear students, you might have come across the words frost heave or frost boil. In snow places or in the case of silty sands, these phenomena are observed in Himalaya region or European countries. This frost heave or frost boil, due to capillarity action only, these conditions are observed. Okay. Now, my dear students, there is a formula called capillarity height. Capillarity is cos alpha upon gamma W into D. Okay. See students, if I consider this as a alpha, a meniscus, this we call it as alpha, where alpha is known as the contact angle, and D is the diameter of the tube, and sigma s is nothing but the surface tension, which is known as the force per unit length. What is sigma s? Force per unit length. Are you following, student? Any doubt in this? So this formula can be simplified as Hc is equal to 0.3 upon D centimeters. What is alpha called here? Alpha is known as the contact angle and D is the diameter of the tube, gamma W is the unit weight of water, and sigma s is the surface tension, which is nothing but the force per unit length. And one more thing, my dear students, I would like to tell you here. See students, we are also have taken, see, whatever the water in this tube, the water will cause compression to the soil mass and the capillarity water will be under tension. They can ask you, how is the water in that condition? The capillarity water, the water which is occupied, the capillarity water will be under, or you can say water will be under tension, okay, instead of capillarity water. Okay, see students, what I would like to tell you, I told you the interconnected voids will act like capillarity tube. If you see here the water, The water is going to cause compression to the walls of the tube and the water will be in tension. The water will be in tension, but it causes compression to the soil mass. Okay. 1 second, students. I have one beautiful question, student. This is one of the beautiful question I would like to explain you. Here, what is the question here is, the soil profile at a site, up to a depth of 10 meter is shown in the figure, not drawn to the scale. Means actually it is not drawn to the scale, and the soil is preloaded. This has a huge impact, my dear student. The soil is preloaded with a uniform surcharge of 70 kilonewton per meter square. With a uniform surcharge of 70 kilonewton per meter square at the ground level. The water table is at a depth of 3 meter. The water level is at a 3 meter below ground level. The soil unit weight of the respective respective soils are given, and assume the surcharge is applied instantly. This is very important, sir. And the surcharge is applied instantly after preloading. The effective stress at P and Q. So he is asking what is the effective stress at P and Q. Sir, there are two terms here I would like to tell you. One is preloaded, and here see, the surcharge is applied instantly. Sir, please remember this. The surcharge is applied instantly, immediately after preloading. Sir, whenever this line, please see here, when it is applied instantly after preloading, then the surcharge will not have any impact. Actually, I told you that whenever there is a surcharge loading, the stress will be uniform throughout the length, I told you. But as it is applied instantly after the preloading, it will not have any impact. My dear student, write this as a note point. So what is the important observation is, whenever there is a surcharge load immediately applied instantly, immediately after the preloading, it will not have any impact, my dear student. So here you can write, suppose if it is 3 meters and if it is 4 meter, you can write what is the unit weight at P, point P. So it can be written as clearly 18 into 3. Are you following, Srujana? So at a point P, 18 into 3, because there is no water table. Sir, see here, water table is here, my dear student. So here there is no surcharge, we cannot take. This is 3 meter. So what is the unit weight here? It can be written as 18 into 3. So at a point 3 P, it is 54. Agree? Now at a point Q, they have given it as 20, my dear students. So but there is a water table. Here, if you observe here, there is a water table. So water table means 18 into 3 is plus, whenever there is a water table, I told you it should be gamma dash into Z. So here 18 into 3. So at point P, you can write it as 18 into 3, my dear students, that is equal to 54. And similarly at Q, it will be equal to 18 into 3 plus, what is gamma dash, sir? What is gamma dash here? Gamma dash can be written as 20 minus 10 into 4. So this will be equal to 54 plus 10 into 4. You can write it as 94 kilonewton per meter square. Sir, so what is the stress values at P and Q is 54 kilonewton per meter square, and you can also write it as 94 kilonewton per meter square. Remember, my dear students, you can, very good Amma, very good Srujana. Why do you want to understand effective stress is, sir, if you want to calculate shear strength. Actually, my dear students, shear strength is a function of effective stress. Okay? Shear strength is a function of effective stress. If you don't know effective stress, you cannot estimate the shear strength of the soil. That means you cannot estimate the bearing capacity. If you want to understand the settlement of a soil, you should know the effective stress. So my dear students, if you want to understand the stress distribution, you should know the sigma dash. So if you want to understand the engineering properties of the soil, effective stress is a very, very important concept. So my dear students, what I would like to tell you is, total stress will be always written as effective stress plus pore water pressure. And the first important point I would like to tell you is, if there is a surcharge, if there is, suppose if in case 1, if there is a surcharge, you have to write that the stress is going to be uniform. In case of surcharge, how is the stress? The stress is going to be uniform. Okay. And next thing what I would like to tell you is, in case of water table, effective stress will be calculated that gamma sat will be replaced by gamma dash. And one more thing, my dear students, I would like to tell you. In case no water table, okay, whenever there is no water table, effective stress will be equal to the total stress. Whenever there is no water table, you can imagine that effective stress will be equal to the total stress. I hope you are clear. In case of stress, in case of surcharge, the stress will be uniform. In case of water table, gamma sat will be replaced by gamma dash. In case there is no water table, effective stress and total stress will be same. And one more thing, students, due to capillarity action, if you see, due to capillarity action, there can be negative pressure as well as positive pressure. So my dear students, I just want to summarize you in a simple words, okay? Minus gamma W into Hc, if Hc is the capillarity height, and gamma W into Hc. Sir, see, this is a beautiful concept. They can ask you, in case of capillarity action, please write it as a note. In case of capillarity action, okay, in case of capillarity action, okay, in case of effective stress, whenever you are calculating the effective stress will be calculated taking gamma sat into account. Sir, whenever, this is a very, very important note, student. I told you effective stress will be calculated whenever there is a sigma dash, effective stress, water table, gamma sat will be replaced by gamma dash. But here I am telling effective stress will be calculated as gamma sat. So they can ask you, my dear student, in case of capillarity action, what is the change in the, in this question can ask. So here first write down that in case of capillarity action, effective stress will be calculated as gamma sat. And there can be question, you can write it as a note. My dear students, please write it as a note. In case of capillarity, what is the increase in effective stress? If anyone asks you is, what is the increase in effective stress? I am giving you the shortcuts also. You can write it as gamma sat minus gamma dash into height of the capillarity height. So these things are very important when you are solving the GATE question. So here what I would like to tell you, student, in case of capillarity, the effective stress is taking gamma sat into account. Okay. I hope you have enjoyed the effective stress concept, students. The basic agenda of effective stress is as simple as that. You should understand that why you are learning effective stress, because the shear strength is a function of effective stress. Why do you want to study effective stress? Is to know the shear strength. By based on the shear strength, we can judge whether the soil is loose or dense. So for any, if you want to understand the settlement also depends on the effective stress. And there can be different soil strata. There can be a single soil, entire the depth. there can be soil with different, there can be clay, then silt. So a soil can be a different composer, and in that soil also you can have different types of loading, pre-loading and post-loading, and also there can be a surcharge loading, or there can be a water table also, or there can be capillarity zone also. So here we have discussed all the cases and how do you calculate the effective stress. And now what I would like to tell you is, with this we are done with the effective stress basic concept, my dear students. I want to tell you proudly that we have achieved last year our toppers in all the respective branches, and these are our single digit rankers. And one more thing students, I've been telling you, if you visit the website IMS India GATE, definitely you'll have my plan session, you'll have GATE zero fee program. In that GATE zero fee program you have 100 plus of free hours. So please enroll this and get the free access of 12 chapter tests, 6 subject tests, and 6 vast GATE papers. Sir, see students, you can solve a problem in 2 ways. But the beautiful thing is, which is the easiest way and which is the generic way. How easily you can adopt the problem solving, that is also very important. And apart from this student, I would like to tell you, in IMS India, we are proudly offering the offline GATE coaching, which is very important for a GATE or any competitive student to grow. As part of this activity, we are providing 800 plus hours of GATE offline coaching, and we are providing the chapter tests, theory books, exercise books, subject test, multiple subject test, advanced level test, my plan session. The key success of IMS India is my plan session, my dear student. What actually is a my plan session is, we are offering one-to-one mentorship for each and every student, where he can convert the weakness also into strength. We analyze the student with all the concepts and what he is actually facing the difficulty. And one more thing student, in IMS India we are coming with a doubt solving portal. Whenever you have posted the doubt, that doubt can be solved within 24 hours of time. And we have online batches also, and this runs throughout the India. And you have we proudly say that we are the only institute which is offering GATE offline GATE coaching at Vijayawada. You can visit our center at Bench Circle in Vijayawada. And remember students, if you are really excited to attend the offline GATE coaching, if you are a resident of Bangalore, definitely visit our IMS Jayanagar office and have a free demo lectures also. Thank you. I hope this foundation course is helping not only for the civil engineering students, we are also doing the foundation course for all the branches. Please visit our YouTube channel and have a glance of all the videos and brush up your foundations, and I hope that you will be success in your GATE exam. Thank you.